Introduction to EAP in IKEv2. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Today, we're exploring one of the most powerful features of IKEv2, the Extensible Authentication Protocol, or EAP. If you've been struggling with VPN authentication, wondering how to integrate with your existing identity infrastructure, or looking for ways to implement multi-factor authentication, this presentation is for you. EAP in IKEv2 is a game-changer for enterprise VPN deployments. Unlike traditional pre-shared keys or basic certificate authentication, EAP opens the door to sophisticated authentication methods that integrate seamlessly with your existing security infrastructure. Think about it. Most organizations already have Active Directory, RADIUS servers, LDAP directories, or cloud identity providers. Why should your VPN authentication exist in a silo? With EAP, it does not have to. You can leverage your existing identity management systems, enforce the same security policies, and provide a seamless user experience. In this presentation, I will walk you through the most common EAP methods, show you how they work with IKEv2, demonstrate real-world configurations, and share best practices from enterprise deployments. By the end, you will understand not just how to implement EAP, but which method is right for your organization. Understanding EAP architecture. Let's start by understanding how EAP fits into the IKEv2 authentication framework. This is crucial because many network engineers often get confused about where EAP sits in the protocol stack and how it interacts with IKEv2. EAP, or Extensible Authentication Protocol, is essentially a framework for authentication. The key word here is extensible. This means it is designed to support multiple authentication methods without changing the underlying protocol. This is brilliant because it means IKEv2 does not need to understand every possible authentication method. It just needs to understand EAP. In the traditional IKEv2 authentication flow, the client and server exchange certificates or pre-shared keys directly. With EAP, IKEv2 becomes a transport for EAP messages. The VPN gateway typically acts as an EAP authenticator, passing messages between the VPN client, the EAP peer, and an authentication server, usually Radius. Here's where it gets interesting. The VPN gateway does not need to understand the specifics of the authentication method currently in use. Whether you are using EAP-TLS with certificates, EAP-PEAP with passwords, or EAP-TTLS with tokens, the gateway simply passes the messages along. This separation of concerns is what makes EAP so powerful and flexible. The diagram on this slide illustrates the three key components: the EAP peer, which is your VPN client, the authenticator, which is your VPN gateway, and the authentication server, typically Radius. Notice how the EAP messages are encapsulated within IKEv2, and how the gateway acts as a middleman. This architecture allows you to change authentication methods without touching your VPN infrastructure. You simply reconfigure your Radius server. I've seen organizations switch from passwords to certificates to biometrics, all without changing a single line of VPN gateway configuration. That's the power of EAP's extensible architecture. EAP-TLS, certificate-based authentication. Now let's dive into EAP-TLS, which I consider the gold standard for VPN authentication. If security is your primary concern and you have the infrastructure to support it, EAP-TLS should be your first choice. EAP-TLS uses mutual certificate authentication. This means both the client and server present certificates to prove their identity. This is different from standard IKEv2 certificate authentication because the certificate exchange happens within the EAP framework, allowing for much more sophisticated certificate validation and policy enforcement through your Radius server. The beauty of EAP-TLS is that it is virtually impossible to compromise without stealing the private key. There are no passwords to phish, and no credentials to brute force. Each client has a unique certificate, and you can implement hardware-based certificate storage using TPM chips or smart cards for even greater security. In practice, I've deployed EAP-TLS for financial institutions and government agencies where security is paramount. One bank I worked with issued certificates on smart cards to all employees. Even if an employee's laptop was stolen, the VPN credentials were useless without the physical smart card and PIN. The configuration example shows a typical strong swan setup for EAP-TLS. Notice how we specify EAP-TLS as the client authentication method and configure the Radius server details. The actual certificate validation happens on the Radius server, where you can implement complex policies like checking certificate revocation lists, validating specific certificate attributes, or even integrating with your SIEM for real-time threat detection. One challenge with EAP-TLS is certificate lifecycle management. You need processes for initial certificate issuance, renewal, and revocation. But modern PKI solutions make this manageable, and the security benefits far outweigh the operational complexity. I always tell my clients, if you can manage the certificates, EAP-TLS is unbeatable for security. EAP-PEAP and EAP-TTLS. Tunneled authentication. Not everyone can deploy certificates to every device, and that is where tunneled EAP methods like PEAP and TTLS come in. These methods create a secure TLS tunnel first, then perform authentication inside that tunnel. Think of it as creating a secure room before checking someone's ID. EAP-PEAP, developed by Microsoft, Cisco, and RSA, is probably the most widely deployed EAP method. It's built into Windows, Mac OS, iOS, and Android, making it a natural choice for BYOD environments. Inside the PEAP tunnel, you typically use MSCHAP version 2 for password authentication, though other methods are possible. EAP-TTLS, on the other hand, is more flexible. While PEAP is limited to EAP methods inside the tunnel, TTLS can use both EAP and non-EAP authentication methods. This means you can use PAP, CHAP, MSCHAP-v2, or even token-based authentication inside the tunnel. This flexibility makes TTLS popular in heterogeneous environments. Here is a real-world example. A university I worked with needed to support thousands of student devices, for example, laptops, phones, and tablets. Deploying certificates was impractical. We implemented EAP-PEAP with their existing Active Directory credentials. Students could connect using their regular username and password, but the authentication happened inside a secure TLS tunnel, protecting against eavesdropping and man-in-the-middle attacks. The configuration on this slide shows both PEAP and TTLS setups. Notice how similar they are from the VPN gateway perspective. The complexity is handled by the RADIUS server. With PEAP, we typically integrate with Active Directory through NPS, Network Policy Server, on Windows or free RADIUS on Linux. The inner authentication validates the user's credentials against AD, while the outer TLS tunnel ensures the credentials are never exposed. One important consideration: both PEAP and TTLS require a server certificate that clients trust. This is your first line of defense against rogue access points and man-in-the-middle attacks. I always recommend using certificates from your internal CA and configuring clients to validate the server certificate's CN and issuer. EAP-MSCHAP-v2 and legacy methods. Now, let us talk about EAP methods you might encounter but should generally avoid. Standalone EAP-MSCHAP-v2 and other legacy methods. I am including these because you will see them in the wild, and it is important to understand their limitations. IKEv2 without an outer tunnel is fundamentally broken. It is vulnerable to dictionary attacks, and tools like Asleep can crack captured MSCHAPV2 exchanges offline. The protocol was designed in the late 1990s when our understanding of cryptographic security was less mature. Microsoft themselves have deprecated standalone MSCHAPV2. So why am I even mentioning it? Because some legacy devices only support EAP-MSCHAP version 2, and you might be forced to use it. I once worked with a manufacturing company that had embedded devices from 2005 that only supported MSCHAP version 2. Replacing the devices would cost millions, so we had to make it work. If you must use MSCHAPV2, here is how to minimize the risk. First, always use it inside a tunnel. For example, PEAP or TTLS. Second, enforce extremely strong password policies. I am talking 20+ characters with complexity requirements. Third, implement additional network segmentation for devices using weak authentication. Fourth, monitor for authentication anomalies aggressively. The diagram shows why standalone MSCHAPV2 is vulnerable. The challenge response mechanism can be attacked offline. Once an attacker captures the exchange, they can try passwords at their leisure. With modern GPU-accelerated cracking, even complex passwords can fall quickly. Other legacy methods to avoid are EAP-MD5, which provides no mutual authentication, LEAP, Cisco's proprietary method, which has known vulnerabilities, and EAP-FAST, without proper PAC provisioning. If you encounter these in your environment, it is time for an upgrade. My recommendation? Use these legacy methods only as a temporary measure while you migrate to something better. Document every system using weak authentication, have a migration plan, and implement compensating controls in the meantime. RADIUS integration and backend architecture. Let's dive deep into Radius integration, because this is where the magic happens. Your VPN gateway might handle the IKEv2 connection, but your Radius server is the brain of your authentication system. Getting this right is crucial for a successful EAP deployment. Radius, Remote Authentication Dial-in User Service, has been around since 1991, but don't let its age fool you. It's still the de facto standard for centralized authentication. When you combine Radius with EAP and IKEv2, you get a powerful, flexible authentication system that can integrate with virtually any identity store. It's important to understand that your VPN gateway does not make authentication decisions, it is just a Radius client. When a user connects, the gateway forwards the EAP messages to your Radius server wrapped in Radius access request packets. The Radius server then does the heavy lifting, validating credentials, checking group memberships, applying policies, and returning attributes that the VPN gateway uses to configure the connection. In practice, I typically see 3 Radius deployment patterns. First, Microsoft NPS for Windows-centric environments. It integrates seamlessly with Active Directory and supports all common EAP methods. Second, free Radius for Linux environments or when you need maximum flexibility. It is incredibly powerful but requires more configuration. Third, cloud-based Radius services for organizations moving to zero-trust architectures. The configuration example shows a free Radius setup integrated with Active Directory. Notice how we configure the EAP module, set up the LDAP connection for user lookups, and define policies based on group membership. This is a common pattern. Authenticate against AD, authorize based on group membership, and return RADIUS attributes to assign VPN properties like IP addresses and access lists. One critical aspect, often overlooked, is Radius redundancy. I always deploy at least 2 Radius servers in different locations. Your VPN is only as reliable as your Radius infrastructure. Use Radius proxy functionality to create a hierarchy if you have multiple sites. And always use Radius over TLS or RADSEC. if your equipment supports it. Traditional Radius uses MD5 for packet authentication, which is showing its age. Multi-factor authentication with EAP. This is where EAP really shines in modern deployments. Multi-factor authentication. If you are not implementing MFA for VPN access in 2024, you are living dangerously. Let me show you how EAP makes MFA not just possible, but elegant. The beauty of EAP is that it can chain multiple authentication methods. Your Radius server can require a certificate, something you have, and a password, something you know, or integrate with modern MFA providers for push notifications, TOTP codes, or biometric authentication. I recently implemented MFA for a healthcare provider that needed to meet HIPAA compliance requirements. We used EAP-TTLS with certificate validation on the outer tunnel, then integrated with Duo Security for push notifications on the inner authentication. Users connect with their certificate, enter their username, and get a push notification on their phone. The entire flow takes seconds and provides strong multi-factor authentication. The diagram shows various MFA flows possible with EAP. Notice how the Radius server acts as an integration point. It can talk to multiple backend systems to validate different factors. You are not limited to one MFA provider. I have seen deployments that use Azure MFA for employees and RSA Secure ID for contractors, all through the same Radius infrastructure. Here is a pro tip. You can implement adaptive authentication based on context. Your Radius server can make decisions based on the source IP, time of day, or device certificate. For example, connections from the corporate network might only require a certificate, whereas connections from unknown locations trigger additional MFA challenges. Free Radius with custom policies makes this straightforward to implement. The configuration example shows integration with popular MFA providers. Most modern providers offer Radius integration either directly or through agents. The key is to test the user experience thoroughly. MFA should enhance security without creating friction. I always recommend implementing SSO where possible, so users authenticate once and get access to both VPN and other resources. Remember, MFA is only as strong as its weakest link. Implement proper enrollment procedures, have a secure recovery process for lost devices, and monitor for MFA fatigue attacks where users blindly approve push notifications. Troubleshooting EAP authentication. Now for the part that will save you hours of frustration: troubleshooting EAP authentication. When EAP authentication fails, the error messages can be cryptic, and the problem could be anywhere in the chain. Client configuration, VPN gateway, RADIUS server, or backend identity store. Let me share my systematic approach to troubleshooting. First, understand the authentication flow. When troubleshooting, I always start by identifying where in the flow the failure occurs. Is the client reaching the VPN gateway? Is the gateway reaching the RADIUS server? Is RADIUS able to contact the backend identity store? Each point in the chain has specific logs and tests you can perform. The most common issue I see is certificate problems with EAP-TLS or the outer authentication method for PEAP/TTLS clients not trusting the server certificate. Expired certificates or mismatched certificate fields probably cause 50% of authentication failures. Always check certificate validity, trust chains, and enhanced key usage fields. The OpenSSL commands on this slide help verify certificate properties quickly. For RADIUS connectivity issues, start with basic network tests. Can the VPN gateway reach the RADIUS server on UDP ports 1812/1813? Is there a firewall blocking traffic? Use RADTest or RADClient to send test authentication requests. If using RADIUS proxying, test each hop independently. When the issue is within Radius itself, enable debug logging carefully. Radius debug logs can contain sensitive information. FreeRadius's debug mode, Radius D-X, is incredibly verbose, but shows exactly what is happening. Look for LDAP bind failures, SQL connection issues, or policy rejections. The example debug output on this slide shows common failure patterns and what they mean. Client-side issues are often the trickiest because you have less visibility. Windows Event Viewer, Mac OS Console, and Android/iOS device logs can help, but they're often not verbose enough. I maintain a test environment where I can reproduce client issues with full packet captures and debug logging. Tools like Wireshark with proper EAP dissectors are invaluable. You can see the entire EAP exchange and identify where it fails. My troubleshooting checklist. Verify network connectivity, check certificates, confirm Radius shared secrets, validate user credentials, review Radius policies, and examine client logs. In 90% of cases, following this systematically will identify the issue. Best practices and security considerations. After deploying EAP in dozens of organizations, I've learned that success isn't just about getting authentication working. It's about building a system that's secure, reliable, and maintainable. Let me share the best practices that separate good deployments from great ones. First and foremost, defense in depth. Never rely solely on authentication. Even with strong EAP-TLS authentication, implement network segmentation, access controls, and monitoring. I worked with a company that had perfect authentication but gave VPN users full network access. When one account was compromised through a targeted phishing attack, the attacker had keys to the kingdom. Always follow the principle of least privilege. Certificate hygiene is crucial for EAP-TLS deployments. Implement automated certificate lifecycle management, because manual processes always fail eventually. Set appropriate validity periods. I recommend 1 to 2 years for user certificates. Implement proper revocation checking. OCSP is preferred over CRLs. And have a clear process for certificate recovery. One client saved thousands of help desk hours by implementing self-service certificate renewal. For password-based methods PEAP/TTLS, enforce strong password policies at the identity source, not just on the VPN. Implement account lockout policies carefully. If they are too aggressive, you will create a DOS vector. If they are too lenient, you are vulnerable to brute force. I typically recommend progressive delays rather than hard lockouts. Monitor for password spraying attacks where attackers try common passwords across many accounts. Radius security often gets overlooked. Always use strong shared secrets. 20+ random characters. Implement IPsec or RADSec between VPN gateways and Radius servers, and monitor Radius logs for authentication anomalies. One pattern I have seen repeatedly is attackers compromising a VPN gateway and then using it to harvest credentials by proxying authentication requests to their own Radius server. The configuration examples show security hardening for different components. Notice the emphasis on logging and monitoring. You can't secure what you can't see. Integrate your RADIUS logs with your SIEM. Alert on unusual patterns, like authentication from new locations or outside business hours, and regularly review access reports. Finally, plan for failure. What happens when your primary RADIUS server fails? When your AD domain controller is unreachable? When certificate revocation checking times out? Build redundancy, test failure scenarios, and document recovery procedures. The best EAP deployment is one that users never notice because it just works. Future of EAP and conclusion. As we wrap up, let's look at where EAP authentication is heading and what you should be preparing for. The authentication landscape is evolving rapidly, and EAP is evolving with it. The biggest trend I am seeing is the move toward passwordless authentication. EAP-TLS has always been passwordless, but now we are seeing methods like EAP-FIDO that integrate with platform authenticators and security keys. Imagine users authenticating to VPN with Face ID or Windows Hello. It is not science fiction, It is happening now. Microsoft's cloud-based certificate services and Apple's managed device attestation are making certificate deployment easier than ever. Zero Trust Network Access, ZTNA, is changing how we think about VPN authentication. Instead of authenticating once and getting network access, we are moving toward continuous authentication and authorization. EAP methods that support session binding and re-authentication are becoming crucial. Your EAP infrastructure needs to support not just initial authentication but ongoing verification. Quantum computing poses a future threat to current cryptographic methods. While it is not an immediate concern, forward-thinking organizations are already planning. EAP's extensible nature means new quantum-resistant algorithms can be adopted without changing the fundamental infrastructure. Start thinking about crypto agility in your deployments. The integration between EAP and cloud identity providers is accelerating. Azure AD, Okta, and others now offer cloud radius services that integrate seamlessly with their identity platforms. This enables sophisticated conditional access policies that consider user risk, device compliance, and location. The future VPN gateway might be a simple IPsec terminator with all intelligence in the cloud. My advice: build your EAP infrastructure with flexibility in mind. Choose solutions that support multiple authentication methods, integrate with modern identity providers, and provide rich logging and analytics. The specific EAP method you choose today matters less than building an architecture that can evolve with your security needs. Remember, authentication is just the first step in a secure remote access solution. Combine strong EAP authentication with network segmentation, continuous monitoring, and regular security assessments. Your VPN is often the front door to your network. Make sure it's well guarded. Thank you for your attendance. Please consider subscribing to the channel.